Hey everyone, we're doing the last new stuff for the circles unit. It's on tangents. Then on Wednesday we're going to be doing areas of circles again, which I know we know. Just going to kind of change it up just a little bit with that stuff. So want to get into tangents. Tangents really doesn't have anything to do with the sine, cosine, and tangent stuff we did last unit. In terms of what the angles are. So don't try to think you can use that to figure out some distances. You can't. So this is something completely different. This is a different definition, which you'll see in a minute. What we're looking at here is tangent of a circle. It's one point. It's called the point of tangency. You'll see a picture in a minute of what it looks like. We're talking about a line coming through from outside the circle to just barely touch the circle. So a common tangent is a tangent line to two different circles that are in the same plane. Remember, everything has to be in the same plane when we're talking about this. So that's some line that kind of just barely touches two different circles as it kind of goes through its plane. You'll see some examples of this in your textbook. A line is tangent to a circle if and only if it is perpendicular to a radius at a point of tangency. And then the last little note, if two segments from a same exterior point are tangent to a circle, then they're congruent. So let's take a look at our example, our picture. We can see we have this line RS where it just barely touches the circle there at point R. That's what we're talking about, the point of tangency. We see that it is perpendicular. We're going to assume it's perpendicular, so we'll kind of put a right angle in here to definitely make it the point of tangency. So now that point is where the RS is tangent to the circle. Same thing on ST, we're going to call this here would be another point where it's a point of tangency. So now it's two line segments that are tangent to the circle from the same point out here. These two sides are going to be congruent. So they're going to be the same measurement. They're also going to be, if we drew a diameter or radius in from P to T, we're going to see that that as well is going to be perpendicular to that radius. So we know that it's a tangent. So as we see, if RS and RP are perpendicular, then we can say SR is the tangent to circle P. Then if SR is tangent to P, then RS is perpendicular to P. And then if SR and ST are tangent, they're both tangent, then we know that they're congruent. So those are the rules about tangency. That's really all you need to think about and know as we're kind of going through this. We're going to see some examples that are going to build on this as we go. So here's our example. We have AB as tangent to circle C. They want us to find X. So I look and say, okay, it tells me that it's a tangent, so I know right away that this angle here at B is a right angle. So now I'm looking and say, okay, we're trying to find X. So I know if I can kind of figure out a right triangle thing that I'm able to do that. What the diagram's telling me is from A to D is 9 units. So I got to figure out what the rest of my hypotenuse is, which we piece together and know that from point C to the edge of the circle, that's my radius again, that's 8. So from A to C is actually 17 whole units. I'm going to write it in blue here. So you can see that this hypotenuse is 17. So now when we look at it, I have my right triangle stuff, and I can kind of think A squared plus B squared is going to equal C squared. So I can say 17 squared is going to equal 8 squared plus X squared. And we kind of think back and know that 8 and 7 is part of a Pythagorean triple. I just want to double check to make sure that it is. I'm pretty sure it is. You should always do this yourself. 17 squared is 289. I know 64 is 8 squared, so plus X squared. When I subtract 64 from both sides, we're left with 225, which I know is 15 squared. So X equals 15. So that tells me that my other side here is 15 units long, whatever the units were. So that's all we're really looking to do in this unit, is just kind of figure out this section of the unit is, what are my tangents, what sides are we talking about, what measurements can I figure out? So here's 6 examples for you to try, kind of work through them, see what you can get. As always, enter your answers into Edpuzzle, and then come back and check what your work was, how you did. Okay, now that you've finished, here are all the answers. They're fairly simple problems. We're told that all the segments are tangent. We were asked to assume that they were tangent if they appeared to be tangent. So we said that they were. We're just going through. Tangent point, same point on the outside of the circle, they're going to be equal. So x plus 3 has to equal 7, so x equals 4. Number 2, we're looking at our right triangle there. They're telling me they're tangent, so that tells me that angle J is a 90-degree angle. I can use the Pythagorean theorem. I see one leg is 15, the other leg is 20. I know that the third leg then is going to have to be 5 times 5 or 25. Again, question 3, tangent from the same point. X is going to equal 12 because the two tangents are congruent. Question 4, again, is another right triangle. We're assuming it's tangent, so angle S is a right angle. Pythagorean triples again. 5 times 3, 12 times 3, so then it's going to be 13 times 3. If you wanted to check your math and kind of go through it, you would find out that that was the same thing. Question 5 was a little different. They gave us an outside part of our line. ZB is tangent or it's tangent. We're trying to find X to be, although they told us the radius was 21. So then I know the rest of YA is 21 plus 8 gives me that whole side is 29. Again, I wrote it in blue. So now I'm going to use the Pythagorean theorem, plug it into my equations, and find out that X equals 20. And then the last one, same thing. We're trying to find the whole length there. So they told me the radius is 24, QR is 17. I'm going to use Pythagorean theorem. 17 squared plus 24 squared is going to equal X squared. That actually works out to be 856. So X squared is going to be about 29.4. There's no way to simplify that down into a radical. So does that make sense? You just kind of looking, remembering that tangent from the same point, those two tangents are going to be congruent to the same circle. Those tangents are going to be congruent. And then make sure you're using Pythagorean theorem and stuff that you might need to know to do other sides. All right, so let's talk about circumscribed polygons now. Again, we had those before. That's a shape drawn outside the circle. And what that's doing is that's going to make all the edges of the sides of the shape are going to be tangent to the circle in one point. It's like the picture on the right is a square. It's tangent to 4 points between GK, GH, HJ, and KJ. We know then as well that the diameter of the circle is going to be equal to the side of the square. The picture on the left, the hexagon, is circumscribed around P, so it's tangent at 6 sides to the circle. So it'd still be able to kind of figure out some perimeters and some areas and stuff using the circles and some information we have from the circles. So here's our example. We're going to try to find the perimeter of our triangle, knowing that it is circumscribed around circle O. So remember, we're talking about points tangent from the same point to its circle are congruent. So if this side here, A to F is 12, then A to D also has to be 12 because it's still tangent, they're congruent. Same thing on my other side. FC is 8, so that makes EC 8. BE is 6, so then DB is 6. So now to find my perimeter, we're just adding up all our numbers or all our sides. So side AB is 18, plus side AC is 20, plus side BC is 14. When we add all those up, we find out that my perimeter is 52 units. Don't know what they are, but it's 52. Does that make sense? That's what we're looking to do when we're kind of looking at these. Okay, so moving on, we're going to do, you have 6 examples. They show up on my slides 2 by 2. So kind of work through them. Actually, they show up on your slides 2 by 2. So do these 2, we'll go over them. Do the next 2, we'll go over them. We'll kind of do them and we'll go over them. Or you can do them all now and then just come back and check all your answers when you finish. You still need to answer your answers into Edpuzzle. So, all right, so the first 2, when we look at them, we got tangents from the same points of our triangle. So we kind of plug in our numbers and find out x equaled 8 because that's what that short side is. They told me the long side was 26. I knew part of that was 18, so that short part of it had to be 8. My other tangent there had to be 8 in that top part. So we kind of plug it all in. I got 26 plus one side. This side is 32. This side is 22. When you plug all that in, you get perimeter is 80. Second one, we had to figure out what the whole side was. I know from here to here is 10, so that makes this side 10. I already knew that side here was 13, so that makes this whole x 23. That being 13 makes this 13. Again, 17 and 17. Again, we add all those up. We have a side of 30, a side of 27, a side of 23. Add all those together, you get 80. Here are the next two. Work on those. Plug your answers in. Okay, here are our answers. We saw we have a square circumscribed around our circle with a side of 16. So it's going to be tangent right in the middle of all the square sides. So my x was 4 because that little bit had to be 8. All my other parts of them were 8. My perimeter is 16 times 4. So that would be 64. Question 4, we were trying to find x. Had to kind of piece together that my tangent piece, the bottom part of our triangle here from that point, from this point to my circle is going to be 6. Then I go from this point of my circle to this edge here is going to be 4, so that makes my whole length there x equals 10. Add in all our stuff, we find out that the perimeter is 24. Hope this is making sense. This is really pretty straightforward. Okay, here's the last two, a little bit trickier, but definitely go through them, see what you can get, plug your answers in the Edpuzzle, and then we will move on. Okay, so here's the answers. X ended up being 8 because the short side of my little side here was 2. The longer side was 6 because that's what it matched up to, so that made the whole side 8. Fill in our other two missing pieces that we knew. We add all our sides together. We get a side of 8, a side of 5, a side of 4, and a side of 7. Gives us perimeter of 24. And then the last one, we had x plus 2 has to equal my side here that's 8, so x plus 2 has to equal 8, so x is going to be 6. Again, that makes this part of that side 8, other side of 4, 4 and a 9. I get the 9 there, filling in, I get a 9 here, and then the 5 up here. So we add up all our numbers, and we get another perimeter of 52. So like I said, I hope that makes sense. That's the tangent section. That's all we're going to do with tangents in this unit, is just kind of figure out what do we have here. So check your homework. There'll be a little bit more challenging problems there. But again, most of the stuff we can do is like find perimeters. We could have asked you to find the areas of the square or even the area of the circle if we give you some pieces. So just kind of make sure you don't have any of those for homework, but you understand how to do them. We will have some in the area unit for the circles, is using tangents to figure out dimensions of our circle to figure out the area. So that's it for today. Hope you understood all that, and I will talk to you tomorrow on the Zoom call.